Today we do begin a brand new topic that you haven't seen in any of your math classes before on logarithms. Logarithms are a tool that is very, very useful as you continue to advance in math. They are used in a lot of problems with Algebra 3, with pre-calculus, calculus, with physics, with engineering as you advance. Today it's going to seem kind of weird. What in the world? Why do we care about that? Why do we want to do that? Please keep in mind this is the very, very first of the basic building blocks of using logs. We've got to get some skills before we start to see some of the connections and some of the applications on these things. We will get there, even this semester still a little bit. So logarithm means exponent, but instead of writing it with an exponent, we can type it out without that. Antilog is the answer that we would get if we take something and raise it to an exponent, equals, and then that answer would be antilog. We're not going to really use the term antilog in here, but I want you to at least be exposed to it. So I think everybody here would agree with me that 10 squared equals 100. And we're pretty used to the terminology. 10 is the base. 2 is the exponent, but we just said exponent means logarithm. Logarithm means exponent. So if that's true, my exponent 2, I could call the logarithm. And then 100, we said that's the answer after we take something to an exponent. So 100 would be the antilog. Now, what we are interested in focusing on today will be converting these to what we call logarithmic form. And if I wrote this very same fact, 10 squared equals 100, in logarithmic form, I would say the log is the exponent. Log and exponent mean the same thing. So the log equals the exponent. And I am going to write it as a log with still the same base of 10. And I'm going to put the 100 in here. So my base is still 10. The little number that's written down low after log is the base. My logarithm is my exponent, and this says log equals 2, so 2 is the logarithm. And yes, I could say 100 is the antilog, but the word we will usually use when it is log base 10 of something is argument. And the correct way to read what I just wrote here is log, and then we say the word base 10, and we put in the word of, because it's our argument, 100 is 2 or equals 2. So any questions with that basic part right there? Then let's put that in the formula list. These two things are equivalent. These mean the same thing as each other. A to the x is b is equivalent to log base a of b equals x. Few restrictions. A, so our base, is any positive number except 1. And the reason that we don't want 1 is 1 to the x is always going to be equal to 1. It's going to be boring. So that's not going to really get us anywhere. So we throw that one out. We don't want to use 0 to a power because 0 to the 0 is undefined and 0 to anything else is 0 and is boring. If I start taking a negative number, and then I define this for all x's, well, if I take it to a negative number to an even power, I'm going to get a positive. And if I take a negative number to an odd power, I'm going to get a negative. And I need it to be just some number over here. So that's not going to work. So we're going to restrict our base to anything positive except for 1. So now if I'm taking a positive number to all of the possible real numbers for x, I'm always going to get a positive answer. So b has to always be positive. So what we've said so far is the base and the argument must be positive. However, we're going to define this x for anything that's positive or negative. So the answers that we get, the exponents that we use, can be anything positive, negative, or zero. That's going to be important because as we start solving logarithmic equations, and we're taking the log of something with an x inside of our parentheses, we need to make sure we go back and check, just like we do with square root equations, that it works. However, all we're going to have to check for is that argument positive? We don't have to crunch through all of the calculations of the whole thing. We just have to go back. Is the argument positive? If not, we throw it away. So far, so good from everybody with this part. All right, let's start practicing going back and forth for a moment between the two forms. Most of these, you guys are going to tell me what to put down. This is the one we just looked at. 10 squared is 100. That's equivalent to log base 10 of 100 is 2. And we want to start reading these correctly. Log base, whatever we see here, of whatever this number is, the argument is, and then we just read the rest of it. Yes? Nope. Nope. That is the log base 10 of 100. It is not 10 to the 100 because that 10 is written down low. It's not written in the regular place where we put something that we're raising to a power. And when we convert these things, it kind of feels like we're reversing the order. If I wanted to take this log base a of b equals x, a is still going to be my base, but instead of being with the b, I don't do a to the b, I take a to the other thing equals the b. I kind of circle around and come back. So 2 cubed equals 8. If I wanted to do that in logarithmic form, log base. 2 is my base here. 2 is still my base here. The log is the exponent. The exponent over here was a 3. So this log has to equal a 3. And then 8 is the argument or the antilog, so it goes there. 2, if I circled back around, 2 cubed equals 8. Everybody okay there? All right, I want you guys real quickly write this one down on your papers in exponential form. Shayla, what are you thinking? And what's my base? So 4 squared is 16. You guys believe that? Good thing I wrote a true statement up there then. So again, 4 stays the base, squared is 16. Okay, Addie, what about this one? Do you guys believe that? So far I'm doing pretty well. I've got true statements up here. Okay, let's go the other way this time. Elias, what would you do with this one? Log base of three to the fourth is 81. Thumbs up, thumbs down. Does that one make sense to everybody? Riley, what would you do with this one? So we're getting a little bit more fluent with this the more we practice. We're getting where we're saying these correctly. Log base 5 of 125 is 3. The log equals 3. The log is the exponent. 3 was indeed the exponent. My last two on this slide have something a little bit special that I want to start pointing out to you, and it'll sink in more as we see a bunch of these. Log base 9 of 9 is 1. Grazia, would you convert that one to exponential form for me? You guys believe that? And that's going to be true anytime the base and the argument match. No matter what you pick, log base b of b to the first is, those are going to cancel out, and all we're left with is a 1. Because anything to the first is that number. So are we good with that one? Okay, last one for another special case. Let's change 43 to the 0 equals 1 to its logarithmic form. Haley? And so what we're going to have, it is also going to be true log of any base of 1 will be 0, because anything to the 0 will be 1, except for 0, and we're not allowed to have 0 as a base anyway on these. So are we good with that? Okay, now let's start solving some equations. So I'll kind of model a couple of ways. For now, probably what you'll be thinking through as you do these is, if it's log form, let me change it to exponential form. If it's exponential form, let me change it to log form. That's always going to be one of the tools that you may use. So if we convert this to exponential form, 2 to the 4th equals x. Can I evaluate 2 to the 4th? What is 2 to the 4th? Everybody shout it out. So by converting between log and exponential form, I could solve that. Another thing that we will do later on when they're harder to evaluate by hand, and we're going to be using calculators on some of these, we can also think about that as exponentiating both sides. And by that I mean I'm going to take my original log base 2 of x equals 4, and I'm going to make both sides be an exponent. They need to be an exponent of the same thing. In fact, they need to be an exponent of whatever my base was here. 2 to the 4th is what I had here. And anytime you have 2 to the log base 2, that's going to cancel out and just give you an x, kind of like what I showed you with that next to last special case. I'm just wanting you to start seeing some of those, so when we get to these harder ones, I've introduced the wording. Melissa? If this had been log base 3, I'd take 3 to this side equals 3 to that side. Oops, I skipped one. We'll choose down at the bottom here. All right, this one. Daniel, can you convert this one to exponential form for me? And do I know how to solve when I have something squared? I got to take the square root of both sides. And I'm used to doing plus or minus, right? However, y is my base. And do you remember what we said about the base in the argument? Must be positive. So I'm not going to include the negative 8. I'm only going to include the positive 8 as my answer there. Okay, one more of these, and then we'll start talking calculator stuff. And Mateo, what do I get here? Okay, so 3 to what power is 81? So I have to just kind of start thinking through, can I figure that out? Let's see, 3 to the first is 3. What's 3 squared? times another 3, 3 cubed is, times another 3, 3 to the fourth is. That's what I want. I had to go to 3 to the fourth, so z had to be 4 in order for that to work out. So some very simple logarithmic and exponential equations so far, starting to get those building blocks. Okay, with logs, we have a couple of special ones. If it is base 10, that shows up so often in actual problems, it's so common that we call it the common log. And because it's so common, we don't even have to write it. If no base is written, it means log base 10 of whatever. And do you buy that as 10 cubed 1,000? So that would make sense. The other special log that we have is going to be base e. E is a number kind of like pi. Pi is a little bit more than 3. E is a little bit less than 3. Never repeats, never ends. And here's kind of some of what it comes out to be if you punch it on the calculator, which we will do in just a moment, using the e to the x button on the calculator. So log base e means natural log. The way that we write that is ln 7.389. ln does not need a base. It means log base e of something. Now, I'm going to warn you right now. Got to fix my typo here, too. I do not want to see any one ends or capital I ends or even capital L ends. This is not a 1. This is not an I. It is a lowercase l for log and a lowercase n for natural. ln means log natural, natural log. The way that I write them so that I can tell what I'm doing is a cursive L and then an N. Sometimes I write them both cursive, sometimes I do like that. But I make sure the first one's cursive so I don't confuse myself and think, oh, when I walk away from a problem and come back, I don't want to think it is a 1N like I'm used to just it being a variable, because it is not. Okay, calculator skills, so have those out. And I'll have my calculator here as well as my chart over here. To get to the logs, they are written in blue up above these two buttons that are to the left of the 1. So find the e to the x button and the 10 to the x button, and we're going to be using those today too. But up above them, ln and log. So if I want log, base 10 of 105, I need to do my control 10 to the x button so that my calculator will say log. So what I am going to do there is my control button over here, and then my 10 to the x button so that I get what's written above it, log. Now notice it gives me two boxes, one for a base, one for an argument. On an Inspire, you can enter any base, except on a test, because I put it in press to test, which blocks you out of being able to do log base 3, log base 7, and so on. On a test, you can do log base 10 and log base e. So if I want to do log of 105, I need to be a little bit careful. What I do a lot of times, though, it's just log of 105, and I don't look real closely at it. And I hit log, and then I just keep going and type 105 and look where it wrote it. And then I try to push enter, and it reminds me I've got an error. So I have to go back and fix it. I can just skip over that box with the arrow. I can type a 10 in it if I want to, but I don't have to take time for that. I just have to skip over it and put a 105 where it really belongs. When I hit enter, the Inspire knows that I meant for that to be a log base 10. Some other types of calculators just have log and don't have the little box down low, because they only let you do log base 10 and log base e all the time. So is everybody okay with that? And then I could write down for this one that I was evaluating, looking at what's on my calculator screen there, that this is approximately 2.021. For natural log, you're going to do the control e to the x button because it says ln up above that. That's not going to give you a box for the base because the calculator knows that it always means log base e. So all you have to do is get the ln, and then you only have one box, put the 105 in it. And Amelia, do you already have what that equals? Others getting 4.654. So I think we're in good shape with that much so far. Now let's talk about if we have e to something. So now we're going to be using this e to the x button, but not control that because we actually want e to the x. So if I want e to the first, type that button and put a 1 in the box and then hit enter. And let's see what you get. And actually have a few more digits like what I put here on the previous slide. That's how I got those digits. I didn't memorize them or anything. All right, let's do e to a few other powers because that will sometimes come into play. What's e to the 10th on your calculators? Kenna, what you got? Others good with that one? And in the interest of time here, let's jump down, do e to the 200. And what do you have, Alex? Boy, getting big exponents there. Let's do one more. E to the 5200. Anybody else getting an error message? Overflow. That means it's gotten so big that the calculator can't display it. So anytime you get that, when you have that overflow error message, you don't write overflow. You just say e to the 5200. You go back to what you had before that you can't get an approximate value on the calculator. Questions there? All right, I have one slide left, I think, with some examples for us to talk through here. So if we want x is ln 0.0052, can we just punch that in on the calculator? Some of your homework problems will just be punch it in on the calculator and write down what you get. JC, what do you have? Thumbs up, thumbs down from others have you. Okay, this one we're going to have to do a little bit of work to get there. E to the x is 51.4. Okay, x is in the exponent. Oh, wait a minute. I've got exponential and logarithmic forms. Can I change this one to the other form and maybe that'll help me solve it? Ella, would you change that one to its logarithmic form? No, we don't do these switch sides. So the log is the exponent, so that has to, the log has to be the x. So the argument has to be the 51.4. But what is log base e? Shout it out. What's log base e? It's the ln, it's the natural log. So now type in on your calculator ln 51.4 so that we can get approximately what x needs to equal. Elias, what you got? Everybody comfortable with that? Now, as you advance with other problems, you're going to start, oh, if I have e to something, I can take the natural log of both sides. ln of that equals ln of that, and ln e is always going to cancel out because that's the log base e of e, and we just have x is the natural log of 51.4 again. And a couple more here. ln of x is negative 4.16. So let's convert that to exponential form. What is my base on ln? So if I change that to exponential form, what do I have? Daniel, what do I have? E to the equals x. So that's what I want to find. So then I punch that in on the calculator. Everybody punch that in. And Amelia, what do you have? Questions for that? Okay, last one, same problem except common log instead of natural log. And wait to punch this. Oh, what I wanted to say on that one. When you have e to something, like we did on those other examples, use that e to the x button for that. Okay, for this one, what's my base? So we have 10 to what? Is our x. For this one, use your 10 to the x button. Don't type in 1, 0, and then that little caret thing. Just jump straight to your 10 to the x button, and then all you have to type in that little box is the negative 4.16. And McKenna, have you punched that in? No, not to the negative 5. It is not 6.918 to the negative 5. The 10 is to the negative 5. The 6.918 is not. So be sure you get that times 10 in there for the scientific notation. Any questions? All right, thanks for helping us through that.